Write each expression by using repeated multiplication and determine the product. So here with the exponent of 3, that would mean that we need 35 or 0.35 times 0.35 times 0.35. We should have 3 of them written out. So there's 1, 2, 3, 4, 5, 6 decimal places in our question. So in our answer, we should have 6 as well. We can pretend those aren't there for the time being and then just stick them in at the end. 5 times 5 is 25. 5 times 3 is 15, plus 2 more is 17. 3 times 5 is 15. 3 times 3 is 9, plus 1 more is 10. Then we're going to multiply that by 35. 5 times 5 is 25. 5 times 2 is 10, plus 2 more makes 12. 10 plus 1 more makes 11. 5 plus 1 more is 6. 3 times 5 is 15. 3 times 2 is 6, plus 1 more is 7. 3 times 2 is 6, and 3 times 1 is 3. So we have 4, 2, 8, 7, 5. That's five place values, but we said we needed 2, 4, 6. So we need one additional spot before the decimal. So we've got 0, 4, 2, 8, 7, 5. Lesson 8 is a digital lesson. So again, if your teacher doesn't have it open for you to use right now, just follow along in the video. Otherwise, you can pull up another tab and try it on your own. Our job is to try and create a triangle with the line segments given. So we're going to line that up on the side there. And then create pieces of the triangle and see if we can get them to connect. How do you think your triangle will compare to those made by the rest of your class? Well, yesterday's lesson, we talked about how an included side, when we had two angles, could create identical triangles. But how would an included angle between two sides work? Are we going to be able to get more than one triangle or just one triangle? I think that since the angle is included, we could only get one. But then again, it didn't tell us that it had to be included. So if one of my classmates put it in a spot where it wasn't between those two sides, maybe they did get a different triangle. So let's see if we can create a different triangle. I'm going to pull these pieces off and see if we can create a different one. And it does look like if I don't include the angle between the two sides, I do get a different version of the triangle. 3. Let's start by exploring what happens when you have two side lengths and an included angle measure. Try to construct a triangle meeting these conditions. So now it is specific that it should be included. So if I put the 6 on the top and the 7 down here on the bottom of this angle, that triangle is formed. And if I swap them, So the 6 is on the bottom and the 7 is on the top. It looks different, but it just looks like the flipped over version of the same triangle, like it's reflected. Were you able to construct a triangle? Yes, I was able to construct a triangle. Describe how you constructed it. I placed the 2 sides on both ways of the angle. Could you construct a different one given the same conditions? No. When I tried to create a different one, it was just a flipped over version of the same triangle I already made, or I already had. Now let's explore what happens when you have 2 side lengths and an included obtuse angle measure. So remember that included phrase means it should be between these 2 sides. So if I changed it, if I modified it so that the 7 is on the other side and the 6 is here, again, it's just the flipped over version of that same exact triangle. How do you think your triangle will compare to those made by the rest of your class? I think the triangle I made will be identical. To the triangle my classmates made. It might be a turned or flipped over version of my triangle. We found that the triangles we made with the given side lengths, and this is the important part, included angles, or included angle because we only were given one, formed identical triangles. When we overlap them, like we did with our classmates, where we traced them and we overlapped our tracing papers, when we overlapped them, they lined up perfectly. Now it says, let's explore what happens when you have 2 side lengths and a non-included angle. Try to construct a triangle meeting these conditions. So we're going to put the 6 here. We don't want to put the 7 on the other side, so we're going to attach the 7 up here to this 6. There's a triangle that can be formed here. Let's see if we switch them. There's a triangle that can be formed here, and there might even be one that's really small. So there are several different possibilities when the angle is a non-included angle. Were you able to construct a triangle? Yes, I was able to construct a triangle. Describe how you constructed it. I placed the 2 sides together and only connected one side to the angle. Could you construct a different one given the same conditions? I was able to create multiple triangles using these conditions. So here it was the one that we ended with, but we saw that there were several other possibilities as well. Now let's explore what happens when you have two side lengths and a non-included obtuse angle. So again, we're only attaching one side to that angle. And then we're going to try to connect. So there's one possibility. Is it the same or is it different if we connect the 7 first and then attach the 6 to, ooh, that one doesn't even form a triangle, it won't reach. How do you think your triangle will compare to those constructed by the rest of your class? I was only able to find one version of the triangle. So I think that our triangles, meaning mine and my classmates' triangles, will be identical. Summarize what you've observed based on constructing a triangle with two given side lengths and a non-included angle. When the non-included angle was obtuse, we created identical triangles. But when the non-included angle was acute, we were able to create more than one triangle. What are the given conditions of this triangle? I have 2 side lengths, and this angle is not between them, it's next to it. So that's 2 side lengths and a non-included angle. Can you make different triangles with these conditions? Yes, because that 40-degree angle is an acute angle. Then it says try to make a different triangle with these conditions. There's a smaller version. What are the given conditions of this triangle? Again, I have 2 side lengths and an angle, but this time the angle shows up between those 2 side lengths. So this is 2 side lengths and an included angle, which we saw always produced the same triangle. So can you make different ones? No. If we swap these, I would like to move this angle, so not to worry. There's only one possibility. What are the given conditions of this triangle? We have 2 side lengths and a non-included angle. Can you make different ones with these conditions? Yes. Well, if I can't move the 6, then no. But if I could swap the 6 to be here, I would be able to make a different one. All right, so that is the end of lesson 8. Check back for lesson 9 coming soon. Make sure your workbook is filled in with any notes that you need from this lesson.